Dakaya. Lucas. Hey, Jesselyn. Hey, Aaron. Jesselyn, just making sure my mic, because I got this fancy $20 microphone. You can hear me, right, Jesselyn?
Yeah.
All right, sweet. I'm going to present my screen. My throat's a little irritated, so that's another reason why I don't want to keep you guys too long. Obviously, if you have any special questions, I want you to be able to ask. But get out your homework. We're going to kind of burn through some homework, answers to see if you guys are doing this correct, mainly. And then the next thing I'm going to assign is just jump right ahead to your sample test. I think the very next thing in your binder and Jesselyn, now that I was thinking about this again today, I'll try to get some stuff printed out for you going into next week. But anyway, the very next thing in your packets would be the sample test. I'll be sure to attach that. Hey, Connor. I'll be sure to attach that sample test, especially for Jesselyn and whoever else needs to do it on Cami. But anyway, hey, William. Let's do this. Camera. William, you can see my paper?
Yeah.
All right. So again, if I start going too fast, just go ahead and stop me. But I just want to make sure that we're all doing this correct, okay? So starting off on the first page, number 6, you should have got 30r to the third, because 6 times 5 is 30, and r times r squared is r to the third. That's where you would technically add exponents, okay? Number 9, what you should have got was 40b to the third, because again, 5 times 8, those are just numbers, and then b squared times b, you would technically add those powers to get b to the third. Number 7, you should have got 12n to the 8th. Correct me if I'm wrong. 2 times 6 is 12. Yeah. So, and then, up here, number 4, you should have ended up with 2 to the 4th. Because 2 to the 1st times 2 to the 2nd times 2 to the 1st. And I guess this equals 16, but I'm not going to nitpick. So hopefully you were getting answers just like that. And again, feel free to stop me if there was others on that page that you were confused about or whatever, but page 2. So again, there was a lot of subtracting of exponents on this page. So number 19, you should have got 5 over 3, because those just reduce, and then p to the third. 10 over 6 becomes that. P to the fourth over p becomes p to the third, which may be the slightly better way to write that, is all in one fraction. 5p to the third, over 3. Number 20 might be good to do here really quick. Number 20, 3 over 10, can't really do anything with that. And then b over b cubed is b to the negative 2 when you subtract powers. But once we got done with like the section 210 notes, this needs fixed, okay? Where you got to move this down to the denominator, and that negative 2 can become a positive 2. So you actually need to go at least one more step here. And so the best way to write your final answer would be 3 over 10b to the positive 2 power. Okay? Let's see. Number 21. 8 over 10. That doesn't divide clean, but that at least reduces to 4/5. And then m to the third over m to the third. When you subtract those powers, you get m to the 0, which you got to remember that anything to the 0 power is just 1. So really, this just ends up being 4/5. You would pretty much need to go all the way to 4/5. Okay. So that's page 2. Page 3. This was very repetitive, you know. So what do we do when we have a power to a power? Jonathan's here. What up? Aaron Connor. Okay. So, Jesselyn. Let me actually call on you to kind of... Like Jesselyn, I don't know if you already did number 29, but if you didn't, just kind of do it here in live time. What's going on with number 29, Jesselyn?
You have to add the exponents.
Add?
Multiply.
Multiply. Okay, look. I don't want to be a stickler or like a nag or anything or a broken record, but we have got to know the difference between like this, where you would add powers. This is where you multiply powers, when it's a power to a power. So this is the answer, k to the 16th. They're all like this, I think, on this whole paper. The only plot twist is like the ones like number 33, like number 32. When you multiply those powers, you get a negative 45, which just means you have to like go one more step to fix a negative power. Okay, so I don't know. Dakaya, what would be the final answer to number 32? Considering we have to fix that negative power. What do you think, Dakaya? I don't know if you're not... There you go. Yeah, you're unmuted. You're thinking?
Yeah.
So how do you change a negative power to a positive power? Do you remember?
No.
You have to move it down to the denominator. So in this case, you would have a 1. You know, because like right now, technically, it's like over 1 in a way. And when you move this down to the denominator, you have like a 1 that has to kind of like fill that numerator spot. You know what I mean? If this had said like 5p to the negative 45, you would have just had a 5 remaining up here. Or if this was like a 7p to the negative 45, then you could have had a 7. But I mean, technically there's like a 1 right there, so it's like 1 over p to the positive 45. So kind of like this one, like number 38, it starts off as a power to a power. So this would be g to the negative 72 power. And to make this a little nicer for like a final answer, it would be 1 over g to the positive 72 power. So there's nothing else, there's no other tricks or anything that pops up on page 3. They're all just like power to a power. Number 29, you were done. You know, number 34, it's s to the 20th, and you're done. But if you have a negative power, you have to fix it. Okay. Moving on to page 4. Starting to get a little more complicated, I guess. Number 41. Connor, what's 41's final answer going to be? Like, what do you do in 41, Connor?
I didn't do that one yet.
Okay, we can try to talk about it live in live time. What do you think we should sort of do first, or what should I write down next, you think?
I literally just did it.
Okay, so what did you write down? Like we like
27A6.
Nice.
6.
Yeah.
Bleh.
But did you say?
No, I said bleh.
Oh.
Because I mispronounced something.
Yeah. So all you got to do here, gang, is you actually can just take this outside power and apply it to the 3 and the a squared. You know what I mean? I would like to make a quick comparison to something random but different. Oh, idiot. Again, you don't need to write this down. I just want to make a comparison so no one gets confused. You know, you got to know the rules. If this was like 3 plus a squared and this whole thing was being raised to this power of 3, you could not just, you know, apply the power 3 to that and that. That doesn't work that way. But when it's all just like one term, I keep doing that. When it's all like one term, like 3a squared, you actually can just kind of like put the 3. So Connor got 27 by doing like 3 to the 3rd power. And then when you do a squared to the 3rd power, that's a situation where you multiply powers. Number 42, same thing. It'd be 2 to the 4th, and then n to the 4th to the 4th, which is 16. And then, yeah, like Connor actually did that to make a 27. You can leave it like that. I don't really care. But technically, 2 to the 4th is 16. And you know what? They're kind of all like this. Let's do 46. Okay? So 46. Aaron, even at like, I don't know if you did 46 yet or not, but if you didn't, then just, you know, let's talk about this in live time. What happens in number 46? Or what'd you get in 46, Aaron?
12AB to the 16th.
Ooh, you're close. Don't feel too bad. Okay, so your first mistake was it's not 3 times 4. You know what I mean? Like, yes, you are correct about b to the 16th. You are. Because that's a power to a power. You know, b to the 4th to the 4th. But that's just a 3. That's not like a 3rd power. That's just regular old 3. In fact, Aaron, technically, you could say that's 3 to the 1st power. You know, and you're doing like 3 to the 1st power to the 4th power. And what you're sort of doing is you're multiplying 1 and 4. You know? So that's not going to be 12. That's going to be like 3 to the 4th power, whatever that is. I think it's 81. But who cares? You know what I mean? 3 to the 4th power, okay? And then I think you also forgot to raise the a to the 4th power, which again, technically, if you want to be very, very thorough about this, like even like overly thorough, is technically that's a to the 1st. A to the 1st to the 4th, which is a to the 4th. You know what I mean? So to recap, you got to raise the 3 to the 4th power, which is, there it is. You got to raise the a to the 4th power, there it is. And you got to raise b to the 4th power, which, there it is, okay? And again, whether or not you go on to say 3 to the 4th power is 81, I'm not overly concerned about that. You know? So kind of like here, Aaron, right, number 48, it would be what, Aaron? Might as well call back on you for redemption. What would happen in 48?
5 to the 3rd, and to the 3rd, and to the 9th.
Perfect. And then, yeah, I think 5 to the 3rd is actually like 125, I think. But I don't think that matters that much to us right now. What matters is, are we properly doing like this stuff with the powers? Okay? And yep, that's 48. And if you made that 125, that's also fine. Page 5. Now look, when we start to get, gang, like, what was that noise? Someone's hands up or something, maybe? I don't know what that noise meant. No one's hand is up? I don't know, I can't. Yeah, it doesn't look like anyone raised their hand or anything. So when you start to get like to page 5 and page 6, there might be multiple things to do. Like maybe not 49, 50, 51, and 52. I think these are just like the previous page. So like number 50 would have been like 6 squared, y squared, but then like x to the 8th. You know, which of course this is 36. But starting with number like 53, there might be multiple things to do. So my overall advice is just do one thing at a time, okay? For me, like I would look at number 53 and I don't know, let's ask, Lucas G. If we're doing one thing at a time, do you think you want to do like what's inside the bubble first, or do you want to like right away do this power of 2 on the outside? What do you think?
I would distribute it first.
Hey, and you're not wrong. You're not wrong. So that's fine. Thanks, Lucas. So you could say 3 squared, x to the 4th, 2 squared, x to the 4th. That's one way to go. Of course, there's stuff left over to do. Definitely the x to the 4th times x to the 4th, which, Jesselyn, how do you do x to the 4th times x to the 4th, Jesselyn? What do we do with those powers?
Add them.
That's right. So that would become x to the 8th. And then, you might want to go with, okay, that's really a 9, and that's really 4. So it's probably best to say that's over, because 3 squared's 9, 2 to the 2nd, just check your calculator. You're perfectly free to do that. 3 squared's 9, 2 squared's 4, and then that makes 36. Honestly, and again, Lucas was not wrong at all. He was perfectly correct. But I think what I would do, and it might be just me, is I might actually clean up inside the bubble first before I apply, because that's another way to go. You could have said this was like 6x to the 4th, and then did this power 2. Either way, you end up with this final answer, okay? So this becomes like 6 squared and then x to the 8th. You know what I'm saying? So yeah, 54 is just like that. 55, 56. So maybe I'll do one more my way, so you could choose Lucas's way or my way. They're both correct. In number 56, I would choose to do 3 times 2 is 6. X times x is x squared. Now I'm going to apply this power of 2. So 6 squared x to the 4th. And if you want to say, oh gosh. Excuse me for a second, Mr. Falk. Yeah, cyber class. Can I call you back in a few minutes? Yeah, all right, bye. All right, final page. Once again, there might be multiple stuff to do. Maybe not 51. Maybe not 59. Oh, gosh, no depth perception. Maybe not 59. Number 60. Nothing crazy. I think we just automatically do the -4 power. You know, like x to that power. Like William, even if you didn't do this one yet, that's fine. Just we can, no rush. What do you think we would get on the next step with number 60, William? And we would immediately be looking at that power of -4 to the whole thing.
That would the x would be positive.
Nice, positive 16, and then the y would be, because -4 times negative. Yep, very good. And so you just have to, now when you get to here, people, you just have to go, okay, that's fine. But a negative power? No. Even if the directions don't say that, you should assume that these are the directions. You know what I'm saying? Like whether or not I or some textbook or some test includes these directions literally, you should think of it as we can't have a -8. So the final answer, we'd have to move this y down to the denominator, and that would be the final answer. Now again, when we get to a lot of these, number 62 and 63 and 64 and 65 and maybe 67, those 4 problems especially, there's a lot to do. 62, 63, 64, and 65. So look, gang, just one thing at a time, okay? In 62, let's see here. Jonathan S. In 62, what do you think the obvious first thing to do is? Because there's probably going to be multiple steps here. Jonathan, what do you think the first step is to do in 62?
The parentheses.
Yeah, like this. And so we would do x squared to the 8th, which we're going to be multiplying those exponents. Good. So we get to here, and then so the x to the 3rd comes down again. A lot of these, the ones I marked, these are gonna be more than one step. So the x cubed comes down, and you get to here, and then you just have to add the powers, because now you're in a scenario where you would add the powers. Here it was multiply the powers, but here it's adding the powers. So the rest of them are kind of just like that. You know what I mean? In number 63, I would do a power of 2 first, as well as over here the power of 0. So on the first step, I would go, okay, this is going to be x to the 12th, y to the 6th, And then, like, let's say you didn't like immediately notice that this whole bubble to the 0 power is just going to be something. Let's say you actually go through the motions of like not distributing, but I can't think of a better word. Distributing the power. So it'd be like x to the 0, y to the 0, because 8 times 0 is 0. And then you add the powers. It'd be like 12 plus 0 and 6 plus 0. So that would be like the final answer to number 63. But anyway, so I guess there wasn't that many like really complicated ones where there was probably like multiple lines of work. So 67 is going to be a little crazy, not crazy, but a little bit, because once again, a lot of these are like one step, except if you end up with like a negative power that needs fixed at the end. But anyway, I'm going to post, like, officially assign the sample test here today. Probably make it due on Tuesday or something. I don't know. But, hey, feel free to sign off now. And obviously this homework is due tonight. And then I'll assign the sample test, which will be due, like, maybe Tuesday evening. But so have a good weekend. And if you have any 1v1 questions on something, then feel free to stick around for a few